Okay, in this video, I'm going to walk you through how to do the schematic, and I'm going to use the VCO one because there is a little bit of an error here. So whether it's the VCO with noise or VCO with mic, there is a little error to fix. It's nothing major, just we just need to pay attention to it. And then I'll show you how to put together the whole schematic. I'll use this as an example, but I'm not going to actually go step by step. So if you're doing this, you're not just going to be able to follow along with me. And if you're not doing this, you'll get the same principles. So this video is for everyone, regardless of which schematic you're doing. And so what you need to do is first download from the tiny.cc/synth parts with the S and the P capitalized. You can find it in the gradebook. Once this video is live, it'll be in the gradebook, the link to download the files. And when you download them, extract them all, open them up, you'll get this. And actually, it'll look probably more like that. Okay, and so then here's all the framework, here's all the parts for every single thing. And what you need to go through and do is delete the parts that you don't need so we can simplify it and kind of have a good starting point. So I'm going to walk through that piece by piece, and you can do it along with me. So here we go. I'm going to zoom in. Okay. Everyone will have the +12 ground and -12. Everyone. Okay. Everyone will have a resistor. Everyone. But then it's after this point. I think everyone has a 9mm pot, but everyone is going to differentiate on all these things. Okay. So let me just kind of walk through what you can delete and what you can't. But I'm going to first start with, not with these parts, because these are actually kind of the most confusing. I'm going to start with the simplest so we can really simplify things down. So first is, right above me here is the VCO, and then this is the VCF, and then this is the VCA-like chip or sub-module. It's actually a whole circuit board with a bunch of parts on it that gets installed in. That's pre-made, you don't have to make it. So if you're doing a VCO, you're going to keep this one. If you're doing a VCA, you're going to keep that one. And if you're doing a VCA, you're going to keep this one. This example, I'm doing the VCO. So I'm going to click the delete the trash can here. I'm going to find the red crosshair. There's a red crosshair. Delete. Delete. I'm going to delete the green text as well because I'm keeping the VCO. That's the one that I'm keeping. Now, if you're not doing a VCO, VCA, VCF, you delete all of them. Okay, now I'm going to go down here. I'm going to go to this section. This is the microphone. This example that I have here is the noise section. So I'm going to delete this microphone. Where's the crosshair? Right there. Okay, and then this is a 555 timer. This chip is used on the VCA and the VCF. This is the VCO, so it's not that. So if you're VCA, VCF, you're going to keep this. Everyone else, delete. And then we've got these single and dual op amps. And as I look here, it looks like I have a single op amp. It just looks like I put TL071. I put the exact op amp, but it's a single one here on the VCO. If you've got a dual, then you'll keep these two, but a single, you'll keep this one. So since I have a single, I'm going to delete those. And we're going to scroll down here. This section right here is for the keyboard, right here. These parts are all for the keyboard. And so if you don't have the keyboard, you can delete them, except, and here's the error, the VCO will want to keep this part. But this part you can keep. It's a 5-volt symbol, but I'm actually going to delete it just because I'm going to show you how to find it anyway. So that's the one like error we have to fix. I'll get it back, but I'm going to delete it for now. Okay? You can also delete it too. It's not hard to find. All right. And then we have this section here. So that last section was just for the keyboard. This section here is just for the gain and headphones, the one that like sends the sound out to the speakers and the headphones. So this, if you're doing that section, keep these parts. If you're not doing that section, delete the whole thing. Okay. All right. Now for the parts that get a little bit more confusing. Okay. I believe everyone's got a jack. Everyone's got a 9mm pot. Not everyone has these transistors. You can see this is the 2N3904. This is the BC549. The VCO and VCF have this one, but not the VCO, not any of the others. And the 2N9304 is used on the noise circuit, which that's the one I'm doing, so I'm going to keep this. Okay. This 9mm dual potentiometer Everyone can delete. If we use it, it'll be on the shifter, which is not one of the options right now. So we'll delete that. Everyone's going to keep the Euro power. Everyone's going to keep the Euro jack. Only two things have the switch. One is the gain with headphones and the speakers for the on-off for the speaker. And then the other one is one of the VCOs, but I don't think it's this one. Yeah, it's the one with the microphone. So I don't need it. I'm going to delete it. Okay. Now we get to the confusing part. Oh, actually, sorry. You can look for the diodes. I know that the VCA, VCF, and the keyboard use it. I don't know if anyone else does. Let me check here. I don't see one on this schematic, so I'll delete it. Okay. Here's the confusing part. It has to do with there are 5 different kinds of capacitors. 5. And so I'm going to write down here on this sheet of paper. I'm going to switch over so I can show it here. All right. Just a refresh of the metric system. Okay. So in capacitors, their part values are small. They're less than 1. And so they end up using picofarads, nanofarads, microfarads, or millifarads. So 1,000 picofarads, that's 1,000 P. And I'm just going to use P instead of having the unit after it because this will apply to it more than just capacitors. But 1,000 P is equal to 1 N, 1 nano. 1,000 N, 1,000 N is equal to 1 micro. And 1,000 micro is equal to 1 milli. Okay. And so what this means is that P is smaller than N is smaller than, this is the mu, the Greek letter mu, and mu is smaller than the lowercase m. Pico, nano, micro, milli. Okay, but in circuits, actually typing in the Greek letter mu, can, like especially on a computer with a keyboard, can be cumbersome. You got to go find that, code or whatever. So we don't actually use the Greek letter mu in this course. When we're typing it into Eagle, we'll use U. So anytime you see the letter U, it's a shorthand for the Greek letter mu, because it's easy to do on our keyboards. Okay, so let me go back here. So the takeaway here is P is smaller than N is smaller than U is smaller than lowercase m. Okay, let's go back. Okay, so here, when you see up here, you see 1N to 220N. That means that a capacitor that looks like this, that's values between 1N and 220N, you're going to use this one. Capacitor that has the same symbol, these two are the same, but is larger, 330N up to 1U, which would be 1,000N, that you use this symbol. And then down here, you have this other one's under 1U, so anything that's a P or an N will be here. And then from 1U to 33U, it'll be this one. 47U and greater is this one. And that's just because even though these are the same symbol, the physical part is actually a different size completely. And so we want to use the right symbol that correlates to the right part, the right size part. Okay. So as I look through my schematic, I'm going to note which ones are which. So let me flop over here to my board, and let's take a look. So I'm going to find some capacitors. Looks like they're over here. So I see one right here. That one says 1U. I'm going to write this bigger so you can see it. That says 1U. So I'm looking for that symbol, then the one that says to 1U. And this one says 220N right there. So that's the same symbol, but it's a smaller part. This one right here says 10U. And then if I go over here to the power section, so you can see I have, this says 0.1U. Okay. So this would be the one that says less than 1U. This would be the one that says 330N to 1U. This would be the one that says 1N to 220N. And then this one is the one that says, I think, 1U to 33U. It's in that range. So you're looking at the symbol, and then you're matching the value. And that's how you're going to find out which parts you're going to use. So on here, it looks like the one that I'm not going to use is the one that's 47U plus. That's the only one I'm not going to use. and I'm going to use all the rest. Okay. All right, let me switch back here. So I'm going to go ahead and delete the one I'm not going to use. Oops, I need to get there we go. I'm not going to use that size. And then here, the 9mm versus the trim pot. So to know which is which, they're the same symbol, but they're different size. One is an actual potentiometer you're going to put a knob on and turn, and the other one's going to live inside of it. You're going to set it up with a screwdriver when you build it, and then you're going to seal it all up and never touch it again. Okay, so to tell which one was which on a schematic, I'll go show you right here because this one has both. Okay, let me get in focus. There we go. So here I can see everything has a part name. So this is fine A. This is back when there were two of them, and there'll eventually be two of them again. So this is the fine control, and this is the coarse control. This is for tuning. And you can see this is B10K, and this is B10K. So this is the name, fine, and the value is B10K. Now, as you look over here, you can see it doesn't have a name like that. It just says R1, R2. And instead of saying B10K or A10K or whatever, it just says the thing without a number in front of it. So these two right here are the 9mm pots. Okay, because they actually have names and like tapers to them. That's what the A, B, or C will be. Like, how does it feel when it turns? And these two are trim pots because they don't have special names. They're going to be set up when we build the thing to make it work right, and then we're never going to touch it again. Okay, so that's how you can tell the difference between the two. So if you have something that's got an A10K or B50K or some letter and then the value, and it also has a name to it, like that's a clear indicator that's a knob we're going to turn. So that's 9mm. And if it doesn't have those features, that's an indicator that's just a little internal trim pot. Okay. All right. Now, what you need to do, if you haven't done so already, is pause this video now, and you're going to go through all of your parts and make sure that you only keep the ones you're going to actually use. Okay? So there are mine. You go ahead and pause the video and get ready. Okay, so what you're going to do from here is you're going to take your printed sheet and you're going to try to match it in Eagle. And so all you need to do is be able to use the move, copy, rotate, flip functions and the net function, and that'll be kind of our first step. So the move function is here. Remember, you have to click on the crosshairs. So here's the crosshair for this one. To click and move. To rotate, I can right-click while I'm moving something, or I can go over here to the rotate function right there and do it while it's not moving. Okay. Then we have the flip function, which you will definitely, I shouldn't say definitely, many of you will have to use for the Euro jack here. You have to flip it around. Okay. You might have to do it for like a potentiometer. Okay. And then we have the copy function. You're going to often need more than one jack or more than one pot, so you can just copy it and make a new one. Okay. And then a reminder, a group function, if you need to move a whole group of parts, say I need to move this whole group around, I can click group, then drag, click and drag, highlight the whole group, and then from here, if I want to do an action, so if I want to move the whole group, I can't just move and hit and go. It won't move the whole group, it'll just move the one. I have to right click and then hit move group when I'm in the move function. If I'm in the copy function and I right click, I can copy the whole group, and there's another copy of that. If I'm in the middle of doing an action that I'm like, oops, I don't want to do that, I can hit escape and I'll stop doing that action. If I do an action on accident, say I delete something, like oops, I can undo, like Control Z on the keyboard, or in the menu up here, it's under Edit, Undo, okay, or Control Z is the quick way. Command Z on a Mac. Okay. And that's kind of like what we're going to do. We're just going to start moving stuff around to make it match. So to do what's just on this page right here, I'd take my jack here, Okay, and I would copy it. Come on, copy function. Okay, looks like I need to flip these two. Where's the crosshair? Oh, there it is. If nothing's happening, it's because you're missing the crosshair. Okay, it looks like I need a ground symbol here, so I'm going to copy that ground symbol in. One there. Put one there-ish and there-ish. Here, let's be consistent. Let me do it like this. Okay, and then we've got our net function, our wire function. Can wire things in like so. Okay, remember to click where there's the circle and then end where there's a circle, and then that'll work. Now, you'll notice here that there are these things above me that say like sign out, V octave in, or there's shorthand for that. So how do you get that here? So first you just do the net, and I'm going to click, and then here, let me zoom in so you can see here, these two here. So I can click here, click again, and then hit escape, and it'll just leave that little nub, that little green nub. I'm going to do the same thing down here. Okay, hit escape, there's that green nub. And then the next step is to, and boy, it got out of focus here. Okay, is to go into the name function. It's right here. Click on that stub of wire, and then type in what you see. So right here, I see V underscore oct in. And I need to be very precise because I'm going to need to use this in more than one location. So I do that. I click on that. There's V octave in. I name this one. It says sign underscore out. So there we go. And if I do all the way to the bottom here, this one says triangle out. Try out. Okay, and then I'll click that there. And what I've done is I've named that wire, so if I go somewhere else in my schematic, and I'll give you an example of where that's going to be, you can see that over here. See triangle out, sign out. V octave in is probably over here as well. Okay, ooh, that's named differently. We'll have to, oh, I think it's on a control. Anyway, bottom line is that naming these things specifically will let them wire from one spot to another without a physical green wire, which will make it look a lot cleaner and a lot less confusing to look at, so there's not 25 wires crisscrossing each other. Only do this when you see it done on the example schematic. When it's not done that way, then it's not necessary. And so there you go. That's what you're going to try to do. You're going to try to rebuild, your whole schematic piece by piece, by part. And it's at this point you can pause the video unless you're doing the VCO. I want to show one thing specific to the VCO, and that is that this symbol right here says 5 volts, but it looks the same as the 12 volt symbol, and so we need to import in the 5 volt symbol so that we can make that correction. So how we do that over here on our schematic is we're just going to click add part. It's going to load it up. We're going to search for plus 5V, hit enter, and then just go ahead and pick the first option there. It'll look like this. Hit OK. And that's now our 5 volt symbol that we will use here in the VCO schematic. I think the other schematics have got that part solved that use 5 volts, but I forgot to do that for the VCO. Anyway, you can go ahead and get after it. Make sure you ask questions of me, check your teammates' work, make sure they're getting going, and then, yeah, check in if you got any questions. Okay, when you get finished, or you're just at a stopping point, and you need to save it. So I'm going to show you what to save it as. You're going to go up File to File Save As, but before you do, you need to know what to save it as. Okay, and so on this sheet of paper here, down in the bottom corner, you can see this long file. This is where it's stored on my computer, and you can see right at the end the name of that thing. So this is VCO-noise, okay? And so how I want you to save it is to use that name, but also your name. So over here, oh, sorry, I need to click right here. I'm going to go up to File, Save As, and I'm going to type in, let's go to the desktop, find your folder, wherever it is. You're going to type in your name, space, and then the name that's on the sheet of paper. So this would be VCO-noise, okay? And then the other thing to do, if you haven't done already, is to verify and update all of the names and values. So if I scroll in here, I'm going to show you how I got this fine A, coarse A, B10K. So getting the fine A is by clicking the name, and when I click here, you can see that I have typed in fine_A. And if I click the value, you can see that if I click here, I've got the B10K value. And so you want to make it match. Now here's where it doesn't have to match. So this is R1. I'm recording a video right now. Thank you. Isis, I'm recording a video right now. Thank you. Okay, that's in the video too, by the way. So here's R1. If your part is named R1 or R2 or R5, doesn't matter. They're just different names for different resistors. Those don't have to match. But you do want the value to match. So this is 20K, yours should say 20K. And if the name here is like a word, like fine or coarse or V octave in is what this stands for, you need to make sure those perfectly match. Those names need to perfectly match. V octave, okay? And then you want to make sure all your values match. So name, values, okay? So on the jacks here, this was a question I had often. If I click here for the name, I'd have V octave for the name here. And then here for the value is actually on these jacks in particular, doesn't matter. You could delete it and it wouldn't matter as far as like that goes. But in most cases, the value matters. The reason why it doesn't matter for the jacks is because they're all the same style. There's just one jack. And so you don't need to like worry about that. Actually, I take that back. The headphone jacks will be different. But other than the headphone jacks, they're all exactly the same style. And even the headphone jacks are pretty much the same. There's just a tiny difference when you go to install them. All right, that's it. Once you're done, go ahead and zip that schematic file and board file and upload it to Eagle. And the next video series will be talking about how to lay out the board.